بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. These are some exercises about section 2.2. Use the given graph of f to state the values of each quantity if it exists. If it doesn't exist, explain why. Okay, we need to find the limit of f of x when x approaches 2 from the left. Well, this is x equals to 2. If we approach 2 from the left, look to the function. The function is approaching 3. So limit of f of x when x approaches 2 from the left is 3. What is the limit of f of x when x approaches 2 from the right? If we approach 2 from the right, look to the function. The function is coming in this direction. 2, 1, approaching 1. So what would be the limit of f of x when x approaches 2? Does not exist because the limit of the right is from the right is not equal to the limit from the left. Okay, since limit f of x when x approaches 2 from the left is not equal to limit f of x when x approaches 2 from the right. What is f of 2? To find f of 2, this is 2 and I go up until I reach the function. So this point will give you f of 2, which is 3. So f of 2 is 3. Limit f of x when x approaches 4. Well, this is 4. And let us approach 4 from the right. If we approach 4 from the right, the graph approaches 4. Why? And if we approach 4 from the left, the graph also approaches 4. So limit f of x when x approaches 4 would be 4 because the limit from the right equals to the limit from the left. And what is f of 4? Well, this is 4. If you go up, this is an open circle. So f of 4 is not defined. Another question for the function a whose graph is shown, state the following. So this is another function. Find the limit of a of x when x approaches -3. Okay, he did not say from the right or from the left. So this is -3. Let us approach -3 from the right. The function is going up to infinity. If we approach -3 from the left, the function is also going up to infinity. So the limit from the right equals to the limit from the left equals to infinity. So we write that the limit is infinity. Limit of a of x when x approaches 2 from the left. So let us approach 2 from the left. This is 2. Approach 2 from the left. Where is the function? The function is going down to -infinity. So the answer is -infinity. Limit of a of x as x approaching 2 from the right. So let us approach 2 from the right. Where is the graph? It's here. It's going up to infinity. Limit of a of x when x approaches -1. All right. This is -1. Let us approach -1 from the right. Oh, this is 1, sorry. This is -1. Approach -1 from the right. The function is going down to -infinity. Approach -1 from the left. The function is also going down to -infinity. So the limit of a of x as x approaches -1 would be -infinity. The equations of the vertical asymptotes. Let us start from the left. This line, which is x equals to -3, is an equation of the vertical asymptote. This line, x equals to -1, is also another vertical asymptote. This line, x equals to 2, is also another vertical asymptote. Sketch the graph of this function and use it to determine the values of a for which the limit exists. This is a piecewise function. Let us sketch the graph of this function. These are the x values. When x is 0 and when x is 1, the function changes the definition. So in fact, we have three definitions, three pieces of this function. If x is greater than 1, so in this region, y equals ln x. So we need to graph this function in this region. Between 0 and 1, we have a straight line, y equals x minus 1. Less than 0, we have another function, which is the exponential function. So let us start from the left. Let us start by graphing the function y equals ex from -infinity to 0, x less than or equal to 0. Well, let us replace x by 0. If x is 0, y is 1. So the function passes by this point. And now choose -1 because we are in this region. If x is -1, this is e to the power -1, which is 1 over x, 1 over e, about 1 over 3. So the graph is like this. This is a part of the graph of ex. We know that it continues like this. And we know that the horizontal line, the x-axis, is a horizontal asymptote. So this is the part of the graph less than 0, when x is less than or equal to 0. Now between 0 and 1, the graph is a straight line. So how to graph this straight line? I replace x by 0, this point. 0 minus 1 is -1. But now, at -1, I should put an open circle, okay? Because x is greater than 0, not equal to 0. And at 1, 1 minus 1 would be 0. So also I should put an open circle here and connect these 2 points to get the graph of the line between 0 and 1. So we need only the portion of this line between 0 and 1. And 0 is not included and 1 is not included. Now to the right of 1, let us graph the logarithmic function. So we replace x by 1. Well, len 1 is 0. So now this open circle is not needed because this point now is included in the graph. Len 1 is 0. And you can find len 2, or you can find len e, which is 2.7. Len e is 1, as we know. So this is the graph of the logarithmic function from 1 to infinity. So this is the graph of f of x. The only problem with the limit at 0, because when we approach 0 from the right, the function approaches -1. So limit f of x when x approaches 0 from the right is -1, while the limit of the function when x approaches 0 from the left is 1. So the limit of f of x when x approaches 0 does not exist. He says, use it to determine the values of a for which the limit exists. So limit exists for all a in R or real numbers except a equals to 0. The only problem is with a equals to 0, the limit does not exist when x approaches 0. Otherwise, the limit exists. Sketch the graph of an example of a function f that satisfies all of the given conditions. Well, I need to sketch a graph of a function f in which all of these conditions are satisfied. Let me start from here. Now, x, this is the x-axis. When x approaches 1 from the left, so 1, x equals to 1, this is important. Now, when x approaches 1 from the left, f of x, the function, should approach 3. This is 3. I'll put an open circle, and I'll let the function approaches 3. So by graphing like this, now when x approaches 1 from the left, the function approaches 3. So the first condition is satisfied. The second condition, when x approaches 1 from the right, we need the function to approach 0. Good. So I'll just draw a graph like this. So when x approaches 1 from the right, the function approaches 0. So this condition is also satisfied. The last condition, f of 1 should be 2. So this is a closed circle here, means f of 1 is 2, and you have to leave these circles open. So f of 1 is only 2, and this graph passes the vertical line test, and it's a graph of a function. Another question. F of x when x approaches -1 from the left. So now let us concentrate on x equals -1, and let us approach -1 from the left. And what do we need? We need f of x to approach 0. So I will put an open circle here, and I'll do it like this. Okay, here we have an open circle. So by this, what happened? When x approaches -1 from the left, f of x is approaching 0. Good. The second condition, when x approaches -1 from the right, f of x approaches 1. So this is 1. We need f of x to approach 1. Okay. So for example, I'll do it like this. So when x approaches -1 from the right, the function is approaching 1. Is f of -1 given? Let me check. F of -1 is 2. Okay, so this is 2. So this would be f of -1. All right, what else? Limit of the function when x approaches 2 is 3. Okay, where is x2? This is x2. I need the limit when x approaches 2 would be 3. Okay, this is 3. So the function should come here. I will leave this open. Okay, and I will let the function approaches 3 and goes like this. So this is an open circle. Okay, and now you can see as x approaches 2, the function is approaching 3 from the right and from the left. Good. What else? What else? We need f of 2 to be 1. All right. So f of 2 should be 1. So this would be the graph of the function f of x that satisfies all of these conditions. Of course, you can change. The function doesn't have to go like this. It can come from here. Anyway, you need just to satisfy all of these conditions in a graph. Determine the infinite limit. Well, we notice that 5 minus 5 is 0. So if we replace x by 5, we will have 6 over 0. And 6 over 0 is not defined. It could be infinity or negative infinity. So in fact, the line x equals to 5 is a vertical asymptote. X equals to 5 is a vertical asymptote. And we would like to know when we approach 5 from the right, what would happen? Will the graph go to infinity or negative infinity? So if you replace x by 5.001, for example, so 5.001 plus 1 over 5.001 minus 5. The answer would be 6001. Okay, so it goes to infinity. So as x approaches 5 from the right, the limit would be infinity. From the left, again, x equals to 5 here is a vertical asymptote. From the left, we are approaching now 5 from the left. Well, this is 5. If you approach from the left, you are coming from here. So you replace x now by 4.999, for example. Okay. And let us see what would be the function. So 4.999, okay, plus 1 over 4.999 minus 5. The answer is negative 5999. If you increase this for 4 nines, 5 nines, this number will increase. This means we are going to negative infinity. So from these two graphs, you understand that the line 1, 2, 3, 4, 5, this line, x equals 5, is a horizontal asymptote of this function. And when we approach 5 from the right, the function goes to infinity. And when we approach 5 from the left, the function goes to negative infinity. So we know the behavior of the function of the graph near the vertical asymptotes. What is the limit here when x approaches 2? Again, you notice that 2 will make the denominator 0. So x equals to 2 is really a vertical asymptote. Either you approach from the right and replace 2, for example, by 2.001, or approach from the left and replace 2, for example, by 1.999. X squared in the numerator is always positive, and x minus 2 to the power 2 is always positive. So 2.001 minus 2 to the power 2 would be positive. 1.999 minus 2 to the power 2 would be positive. So the answer of this limit would be always positive. This means the limit always infinity, whether you come from the right or from the left to the line x equals to 2. So this line is a vertical asymptote. If you come from the right of 2, the graph will go to infinity. If you come to the left of 2, the graph will also go to infinity. Now for this function, you should remember the graph of L and X. This is the graph of L and X. And this line, which is x equals 0, is a vertical asymptote for the limb. So from here, we know that when we approach 0, when x approaches 0 from the right, the graph will go where? Approach 0 from the right, the graph goes where? To negative infinity. So look here, if x approaches 1 from the right, so as x approaches 1 from the right, what happens? Square root of x minus 1 approaches 0 from the right. Because square root of 1.001 minus 1 would be a number closer to 0. So when this quantity approaches 0 from the right, this means that ln, this quantity, will approach negative infinity. So the limit would be negative infinity because this number or this quantity approaches 0 from the right. And ln x, when x approaches 0 from the right, is negative infinity, the limit. What is the limit of this quantity or this fraction? Well, if you factor, let us factor the numerator, for example, and the denominator. If you look carefully to the denominator, this is a perfect square, in fact. This is x minus 1 to the power 2. X squared minus 2x plus 1. So 1 will make the denominator 0. So we have x equals to 1. This is an equation of a vertical asymptote for this function. And since this is 2, okay, let us now approach 1 from the right. What would happen? We will replace x by 1.01, for example. So if you replace x by 1.1, let us say 1.1, the numerator is positive, the denominator is positive, so the answer would be infinity. And if we replace x, if we approach now 1 from the left, this means we will replace x by what? By 0.99, for example, okay? Or let us say 0.9. This is 1, this is 0 if you approach from the left. So use 0.9. Again, if you use 0.9, the numerator is positive. The denominator is positive because of this 2 of the square. So it would be infinity. So the limit is infinity. And for this function, the line x equals to 1 is a vertical asymptote. And the function is approaching this line from right and from left and is going to infinity. Find the vertical asymptote of this function. You find the zero of the denominator. So 2x equals -4 or x equals -2. So the line x equals -2 is a vertical asymptote. Let us check that. Let us find the limit when x approaches -2 from the right of f of x. Well, this is -2. And here we have -1, 0. And here we have -3. If you approach -2 from the right, okay, I will use, for example, -1.9. Replace x by -1.9. The numerator is negative. 2 times -1/9, 2 times -1.9 plus 4 would be positive. Negative over positive is negative. So the limit when x approaches -2 from the right would be negative, while the limit when x approaches -2 from the left, when you approach -2 from the left, okay, you will use, for example, -2.1. Okay, here -2, here -2.1, -2.5, -2.9. Okay, so you will use -2.1. The numerator would be negative, but 2 times -2.1 plus 4 would be also negative. Negative over negative would be positive. So in fact, for this function, the line x equals to -2 is a vertical asymptote. And when x approaches -2 from the right, the graph goes to -infinity. And when x approaches -2 from the left, the graph goes to infinity. For this function, when we factor the denominator, we will have 3 minus 2x. Now, if you put the denominator equals to 0, so we will have either x is 0 or, so this is a vertical asymptote, or 3 minus 2x is 0. So 3 equals to 2x. Or if you divide by 2, x would be 3 over 2, 1.5. So this is another vertical asymptote. So we have two vertical asymptotes. And let us check the behavior of y, the function, when x approaches 0 from the right. When x approaches 0 from the right, we replace x by 0.1. This is positive. The numerator is positive. And 3 minus 2 times 0.1 is positive, times positive. So the limit is infinity because everything is positive. But to find limit y when x approaches 0 from the left, we will replace x by -0.1. Okay. So just use -0.1. Find -0.1 squared, which is you replace x by -0.1 plus 1. Of course, the numerator is always positive. So I'll just check the denominator. So I will multiply -0.1 times 3 minus 2 times -0.1. Well, the denominator, the calculator tells me that the denominator is negative and the numerator is positive. So positive over negative is negative. So the limit is -infinity. For 3 over 2, let us approach 3 over 2 from the right. So this is 3 over 2, 1.5. If I'm approaching from the right, I'll use 1.6. The numerator is always positive, so just multiply 1.6 times 3 minus 2 times 1.6. The calculator says negative, so this is negative infinity. And when we approach 3 over 2, when x approaches 3 over 2 from the left, I'll use, this is 1, so I'll use 1.4. So multiply 1.4 times 3 minus 2 times 1.4. Calculator says positive, positive over positive, positive. So the limit is infinity. So let us see what we have. The line x equals to 0 is a vertical asymptote. From the right, the graph goes to infinity. From the left, the graph goes to negative infinity. 1.5 x equals to 1.5 is also a vertical asymptote. From the left, the graph goes to infinity. So this will do like this. Okay. And from the right, the graph goes to negative infinity. Of course, I'm not sure whether this will go down or up from where, but so it's better not to sketch it like this. I'll just say like this. Okay. That's it. This is the end of this section. I hope you enjoyed the lesson. The limits are easy. Just study them again and again, and good luck.